Hi, in this video, we're looking at the lower block signs for primary 3 and 4 in energy, and specifically we're looking at the topic of heat. And these are some exam questions that have appeared in either CA1, SA1 or SA2 before. Study the two setups below. So basin of hot water, drop of ink here, air, setup K, basin of cold water. Alright, so even before we look at the question below, I just want you to quickly understand what the question is probably going to ask. So there's a drop of ink over here, hot water. So when you see hot water, you will probably see along the lines of the air is going to expand, okay? And when you see cold water, you are probably going to see the air is going to contract, all right? Or expand is also known as increasing in volume, contract is reduce in volume. All right, so if there's a drop of ink over here, all right, drop of ink, what's going to happen is that this ink they're going to ask you probably whether this ink is going to go up or go down, and why is it going to go down or up. Okay, so if there's hot water, the air inside will increase in volume, and therefore the ink will be pushed upwards. And when there is a cold water here, the air will reduce in volume, and therefore the ink will will go downwards. All right. So this is something that you must understand even before you read the question below. All right, let's look at this. So take what would happen to the drop of ink in setups J and K. So setup J would go upwards. Setup K would go downwards, and nothing would remain the same. So the second part of the question is explain your answer. And this is a very common two-part question, A and B. The first one is to state your observations. All right, what do you actually see with your eyes? Okay, so you see this thing go up, or you see this thing go down, or the drop of ink go left or right, whatever. So the key thing is to what do you observe? What do you see with your eyes? And then the second thing, the second part of the question will always ask you explain your answer, which is why does the thing you observe actually happen? All right, what are the scientific principles or the scientific reasons behind the observation, or what do you see with your eyes? And you have to ask yourself two very critical questions. And the first question is, why does that happen? And so what? All right, so what if that happens? And you have to present to the teachers a logical train of thought, a scientific train of thought as to all the sequences and the consequences, so that the teachers will understand that you really know your work. Okay, so the first thing you must write down in your answers is always what happened initially. All right, so the initial state, what happened? And the initial state is there's a basin of hot water. There is some kind of a flask. There's air inside. That's the initial state. Okay, so you have hot water, you have some kind of air, and you have your drop of ink. And the final state, all right, so initially, so what happened at the final state? The final state is the ink moved upwards. All right, so ink moved upwards. So the teachers, when they say explain your answer in setup K, they want to know, initially I have these conditions. What happened such that my ink moved upwards? What are the scientific explanations that can show, that can help me understand why my ink moved upwards? And the trick to do this, right, is to constantly ask yourself, so what? All right, so what? I'll show you how to do it. So I'll explain your answer for setup K. So there was a basin, the air, let's say I call this the flask of air in basin of hot water. All right, so that's the initial conditions. That's actually what happened initially, or that's what the experimenters did. There's nothing scientific about this, all right? So it's just, you're just describing what actually happened. Now the next thing is, so what if there is a flask of air in a basin of hot water? All right, so what a lot of kids will do is that they will say the air will expand. All right, but is that true? Is it because of the flask of air in a basin of hot water then the air will expand? All right, you're actually missing out something in between that states why the air will expand. All right, so let me just write this for you. And the reason why the air expands is because the heat is transferred from hot water to the air. All right, I write shortcut here. Please write properly in your own notes. So the heat is transferred from the hot water to the air because the hot water is hotter than the air. All right. Now, they didn't state this, but I'm just writing this to be extremely clear. Now, if the air, if I just write air here, so it's probably going to be cooler than hot water, but if I write here hot air, then it might be that the air is transferring heat to the hot water, right? Depending who is hotter, because it's always the hotter transferring to the cooler. Okay, so hot water is cooler than the air, so heat is transferred from the hot water to the air, and after heat is transferred, so the air will expand and increase in volume. All right, so that's heat is transferred, then the air will expand and increase in volume because, why does it do it? Because air has no definite volume, right, and shape. I mean, if you want to be very clear. So air has no definite volume and shape. That's why the air will expand and increase in volume. And because of the expansion of the air, so the expanded air will take up more space. All right. And so what if it takes up more space? So what if it takes up more space? So it will push the ink upwards. Okay, so let me just quickly go through this again. They asked you to state your observations and you say the air moved upwards. And the next part of the question is always going to be explain why. Why did the air move upwards? And the way to answer this kind of question is to first tell them what happened initially. What's the initial conditions? What are the things that happened initially? And then after that, tell them the last condition, the last thing that you observe, which is the ink moving upwards. And you have to keep asking yourself why and so what in between, and give scientific explanations to bring it to the final state, all right, or the final thing. So first of all, the initial condition is there was a flask of air in a basin of hot water, all right? Okay, so what? All right, so what if there's a flask of air? The next thing is heat is actually transferred from the hot water to the air because the hot water is hotter than the air and heat transfers from the hotter to the cooler. And so what if heat is transferred to the air? All right, so air will expand because it's heated up and will increase in volume because air has no definite volume and shape. And so what if the air expands? All right, the air will then take up more space. And so what if the air takes up more space? The air will push the ink upwards, all right, because it takes up more space. And now you have actually linked the initial condition, which is a flask of air in a basin of hot water, to the final condition of pushing the ink upwards, all right, and you have given a scientific explanation of each step that takes place in between the initial and the final state. And that's how you answer a 2-mark explain your answer science question. James wanted to find out which material A or B can be used to store cold drinks. He then prepared the setup as shown below. He poured the same amount of drinks of 80 degrees Celsius into 2 cups made of materials A and B. Okay, so let's take a look again. Material A, water at 80 degrees Celsius. Material B. So this probably, just looking at this question, is probably something going to do with some kind of variable, all right? So as a science student, you must understand that any experiment, there can only be one variable, all right? So when I see this, I know that there's one variable, which is material A and material B. But instantly I can see another variable, all right? The surface area is different, all right? The volume might be different as well, okay? So store cold drinks. So store cold drinks, some kind of insulator / conductor. All right, is the material a good insulator, or is the material a good conductor of heat? Something along these lines, this question must be asking. All right, so let's take a look at the actual question. His teacher told him that his experiment is not a fair test. State 2 variables that he needs to keep the same for a fair test. All right, oh, cool. So I've already written here. So he needs to keep the surface area of the container the same. All right, or if you find the word surface area too difficult, then you just say he needs to use the same container. And the second one is he needs to keep the same volume of water. All right, because if one of them has very little water and one of them has a lot of water, then this is not a fair test. Okay, after making the necessary change to ensure a fair test, he carried out the experiment. He used a data logger and 2 temperature sensors to measure the changes in temperature of the hot water. Results of his experiment are shown below. So material B, it's this line, material A is this line. Okay, let's take a look at this graph first and make sure that we understand this graph. So basically this line is what you call the room temperature. All right, so eventually whatever material you use will eventually end up at this temperature. And if you continue the graph, material A's curve would look something along like that. Okay, so material A will also be at room temperature faster, but it takes a longer time for material A to be at room temperature. And also at, let's say, minute number 8, you want to see who is hotter. Material B is about 40 degrees, but material A is, let's say, about 60 degrees. So material A at 8th minute, all right, is 60 degrees, but B is 40 degrees. So if I want to store cold drinks, I want to find the better insulator. So if I want to rank, so A is a better insulator than B, all right? So as usual, I draw my upward downward slope, all right? So A is a better insulator than B if I rank them. And if I want to store cold drinks, then I would want to use A as well, because it insulates heat better. Okay, so let's take a look at the question. James chose to use material A to make a container for storing cold drinks. Again, explain his choice. So in this explanation, you must write the keyword, which is insulator. Okay, so you must say that A is a better insulator. All right, why is A a better insulator? All right, so A is a better insulator, and again, you ask yourself, so what? All right, so what if A is a better insulator? It will it will prevent the air from transferring heat to the drinks longer. Okay, or you can say it will keep the drinks, you can also say it will keep the drinks cold for a longer time. All right, so that's why he chose it, because it's a better insulator. And so what if it's a better insulator? It will prevent the air from transferring heat to the drinks for a longer time, or the second possible answer, it will keep the drinks colder for a longer time. An empty bottle which was sealed with a cork was heated. 2 minutes later, the cork popped out. So there's some cork, it's an empty bottle. 2 minutes later, so it's not really empty. There's actually something inside called air, and you heat it, so the air will expand, and therefore it will take up more space, it will take up more volume, and it will push the cork out. Something similar to the ink drop question just now. So let's take a look at the answers. So which of the following best explains the above observation? The air outside the bottle gained heat and expanded. All right, is this correct? Nope, this is not correct, because it's not the air that gained heat. The air inside the bottle gained heat and expanded. All right, that is correct. Okay, so this is not correct. The air inside the bottle lost heat and contracted is not correct, because there is a candle flame here, so there will be heat transferred. There will be heat transferred. Okay, the bottle lost heat and contracted. That's not correct, because there's a candle flame there. So the answer is number 2. Okay, let's. Amina made a cup of hot tea for herself. She then left her cup of tea on her dining table as shown below for 15 minutes. So there's a metal spoon, hot tea, glass cup. So just a gentle reminder or refresher that heat is always transferred from the hotter to the cooler. All right. So in this case, you have hot tea, you have a glass cup. So therefore, the heat from the hot tea will be transferred to 2 places. Okay, one of them is the glass cup, which will then become hot, and the other one is also the metal spoon, which will also become hot. Which one of the following describes what was happening to the cup, the cup and the tea during the 15-minute duration? So the glass cup. So again, glass cup will increase because heat transferred there. Hot tea will decrease. So hot tea will lose heat. This too is correct. Glass cup will gain heat because the hot tea is losing heat to the glass cup. So the glass cup will gain heat. So this is wrong, this is wrong, this is wrong. So the answer is number 2, all right? Because the hot tea will lose heat and the glass cup will gain heat. Phyllis was given a metal rod. The metal rod was coated with candle wax at parts A, B, C, and D. The metal rod was heated over a candle flame as shown below. So candle wax here, here, and here. All right, so over here. So the idea is that the nearest will melt first, okay? And the furthest will melt the last, okay? So, and it's the nearest to the candle flame. So my candle flame is here. The nearest wax is actually here. So this is number 1. The second is this, number 2. And if you measure, this is number 3. And this is number 4. So the nearest to the candle flame will melt first. The furthest will melt the last. Hey, wait a minute. No. This is wrong. 1, 2, and then this is 3, and this is 4. Okay, so this is nearer than this. So in which order would the wax first melt? So number 1 is B. First is B. Okay, correct. Number 2 is C. Correct. Number 3 is A. Correct. Number 4 is D. Correct. So the answer is number 4. Which one of the following is not a source of heat? A sweater, a candle flame, the sun, a lighted gas stove. All right, so let's look at candle flame. Candle flame produces heat and light. Okay, so it is a source of heat, Therefore, this is not the answer. The sun is our primary source of heat and light, so therefore this is not the answer. A lighted gas stove is actually a source of heat as well, right? Because it produces heat energy by itself. So it's not the answer, and the answer is a sweater. Okay, so a sweater does not produce heat. What it does, how it makes you feel warm is that it traps. Okay, it traps the heat from your body. Okay, so it does not produce heat. It's not a source of heat. So the answer is number 1. Ahmad conducted an experiment using 2 rods of the same size as shown in the diagram below. He recorded the time taken for the wax to melt. Alright, so rod here, there's a glass and there's steel, some kind of candle over here, wax. So what time, he wants to know when will the wax melt, okay? So even before looking at the questions, you probably know that he's trying to test which is a better conductor of heat, because the heat from the candle will travel upwards until it reach here and then it will melt it. Likewise for the glass, it will travel upwards until it reach here and it will melt it, okay? So he wants to know which is a better conductor, and if you're looking at steel and glass, you should know by now that steel is a better conductor than glass, okay? And so therefore this should melt first. So state the likely aim of Ahmad's experiment. So the likely aim is to find out which material, glass or steel, is a better conductor of heat. Okay, so that is the likely aim, to find out which is a better conductor of heat. Based on Ahmad's aim as stated in part A, put a tick in the appropriate column to indicate which variables are to be changed, kept the same, or used as results in his experiment. So let's look at it. The length of the material. So let's go up to the thing again, alright? And we say that you want to find out which material is a better conductor of heat. So therefore, if I want to find out which material, therefore the changed variable should be this one, alright? So the material is the change variable. That's how I can tell which material is a better conductor of heat, and everything else should remain the same. And the measured variable should be the time for the wax to melt. Okay, so that should be the measured variable, the time for the wax to melt. The changed variable is material. Everything else should remain the same, be it the length of the string, the volume or the shape of the what's this, rod, or the size of the candle, or the heat of the candle. Everything else should remain the same. All right, so let's take a look at the question. So length of material should be the same, amount of wax used should be the same, time taken for the wax to melt should be used as the result, all right? Because the faster it melts, the better the conductor. The slower it melts, the lousier the conductor, or the better the insulator. Distance between wax and the flame should be the same as well. So this is quite an interesting question because they don't show you whatever that's supposed to be changed, but the thing that's supposed to be changed should be the material of the rod. Okay, so that should be changed. Used as results is the time, and the rest, everything else should be kept the same.